My name is Kyla Sjogren, and I want to talk to you today about a day in the life of a t-shirt. So according to Matthias Wallander, CEO of Use Again, each year over 2 billion t-shirts are sold worldwide. But how and where is the average t-shirt made, and what's its environmental impact? Before we begin, I want everyone to pause and think about that last t-shirt you bought. How much was it? Do you still have it? Is it wearable? Does it have a hole in it? Just at a glance, there are many steps involved for one of the most basic items in our closet. Here's a snapshot of the processes that we're going to walk through today. After reflecting on that last t-shirt purchase, did you ever think there were this many steps involved? Let's start to unpack those steps. All right, so cotton begins its life on a farm. The three top growers of this crop are China, India, and the US. I've chosen to focus on US grown cotton because they're the third largest cotton producer globally, and the data on this country has been easiest to vet. In the US, 90% of cotton seeds are grown in the lab. They're genetically modified by corporations like Monsanto and BASF. They're modified to protect against disease, pests, and to create optimal growth. In this scenario, the farmer does not own the seed, but they can use their seeds for other products. I'll talk about that more in a second, but they aren't able to actually save the seed and replant that seed. In addition to these super strains, US farmers are granted subsidies to grow cotton. This can sometimes give them a competitive advantage over other global growers. It enables them to purchase machinery that mechanizes most of the processes. I found that the median income for the US cotton farmer is $63,000 a year. Most of these farmers also grow other subsidized crops. Those are soy and corn. On the other side of this, cotton is controlled by commodity pricing in the US. One year, a farmer can sell their cotton for 75 cents a pound, and the next year it can sell well under the price of production. This environment can be very volatile for the farmer. The seeds are sown and irrigated to produce the fluffy bolls you see in the image on the right. I'll talk about that chart on the left. It takes about 160 days from seed germination to harvest. Much of the harvest is done using self-driving machines. It has been stated that the largest environmental footprint for the t-shirt is water usage. When I started this research, I found many differing statistics. Most of these numbers vilifying the water usage of cotton farming. I want to take a second and talk about this. Whenever you hear, read, or see a statistic, be skeptical. Google it, find the data source. Was it from a scientific report? How was the data collected? The craziest metric that I found was that 1 kilogram of cotton takes around 20,000 liters of water to grow. That's insane. Like, why are we even growing cotton, period? It doesn't make any financial sense. However, be skeptical because there's a lot of marketing out there to sway consumers like you. Dig deep when you're looking this information up. In a report that was just released by Transformers Foundation, I found the following data that I'm willing to stand behind. It takes 1,931 liters of irrigation water and 6,003 liters of rainwater to produce 1 kilogram of cotton lint. That's roughly equivalent to the t-shirt and the jeans that I'm wearing. In US measurements, the total of those water calculations together is 2,096 gallons of water for 2.2 pounds of cotton lint. These numbers don't factor in the water used to manufacture the garment, and I'll talk more on that later. And I'm going to talk more about this cotton plant, and then I'll go to the chart on pesticides, but I'm talking a lot about it because in this research that I conducted, the thing that I'm most interested in, the thing that really got me excited was just learning about this industry and learning about the plant. Cotton is actually a xerophyte. It's adapted to breed and to survive in drier and more arid climates. Cotton farmers' water usage varies dramatically, and those variations are influenced by so many factors, including but not limited to climate. Cotton got its reputation as water thirsty because it is in fact grown in many water-stressed regions. But there's more to the story than meets the eye. Farmers in dry climates often choose to grow cotton precisely because it can survive and produce a crop in harsher environments. Farmers grow cotton in these regions often because it can withstand the climate better than other crops. Any data about cotton's environmental impacts older than 5 years should be questioned. Data older than 10 years should be considered outdated and not used or used with a disclaimer. To naming an example, in the US, cotton farmers in the Southeast, where it rains more often, use 234 liters of irrigated water per kilogram of cotton, on average to farmers in the West, which use 3,272 liters of irrigated water per kilogram. More to the point, global averages also fail to capture impact. 20,000 liters sounds like a shocking amount of water, but so does 234 liters. But in fact, these figures alone don't reveal anything about whether water is sustainably managed on a local level where cotton is growing. According to Alan Williams of the Cotton Research and Development Corporation, he says, cotton is not among the largest users of irrigated water globally. It takes less water per hectare than rice, wheat, maize, soybeans, and many vegetables. And it just seems like I did a little bit of research and wheat does take the most amount of water, so maybe we should stop eating bread. Just kidding. Let's talk about the chart you've been looking at. Along with water usage, cotton has a poor reputation for pesticides. According to the Organic Trade Association, conventional cotton production soaks up 16 to 25% of the total pesticides worldwide, even though the crop itself only covers about 2.5% of the world's total agricultural land. I have read so many statistics that say, the same thing, that, 25% of all the pesticides in the world are for cotton. And it's just, it seems so insane. So I dug a little bit deeper, and in that same report that I'm referring to from the Transformers Foundation, they say pesticides are not one thing with one single type of impact. Farmers use a variety of pesticides that target different organisms. Understanding the pesticide uses and impacts requires familiarizing yourself with all the kinds of pesticides that are used on cotton and why. There are a range of approaches to managing pest in farming. Not all rely on synthetic pesticides. Organic farmers, they don't use pesticides, so what are they doing? Over time, as farming practices have evolved, some cotton farmers have moved away from a chemical-intensive approach towards something called integrated pest management. There are major data gaps about cotton's pesticide usage. There's an urgent need for country-specific data on the volume of specific formulations, products used, and sales data per active ingredient. The chart on the slide describes a few pesticides used. I'm not finished though. That's not the last chemical we're going to talk about that is applied to cotton. So when you see cotton in this state on the slide, the thing that has happened to it is called cotton defoliation. It's a process that naturally occurs when plants shed leaves at maturity. This usually occurs naturally after a frost, but sometimes because cotton is grown globally in warmer and wet regions, the rain can compromise the crop. You don't want too much moisture in that cotton fiber bowl. So farmers actually apply a defoliant. I'm not going to delve into that, but I want you to know that aspect too. All right. So because of commodity pricing and the fact that farming is very difficult, cotton farmers have had to be savvy. There is more than one use extracted from the plant. The seed can be used for cottonseed oil, it's really good for frying, and feed for livestock. Cottonseed is often fed to cattle and horses as a healthy source of protein. Humans can't digest the cellulose found in cotton, but animals have a special enzyme that break it down. Even stalks and stems from the cotton plant can be made useful. Stalks are plowed underground to enrich soil, and fiber extracted from them is used to make pressed paper and cardboard. Additionally, cotton serves as a function in just about every single industry, from pharmaceuticals to rubber to plastics. And also, it also has like a shorter fiber and a longer fiber. The longer fibers are used for t-shirts and other cotton garments, but the short fibers can be used in x-rays, swabs, cotton buds in the medical field, as well as clean room suits and supplies. But I want to focus on that t-shirt. So everybody's going to know about a cotton gin after this is done. I'm going to have a test afterwards, just kidding. But I learned about the cotton gin in school, and I had no idea before doing this research of all the steps that this one singular cotton ginning process does. But let's talk about what cotton ginning is. So after it's harvested, the cotton goes to the gin. The purpose of the gin is to separate the fiber from other vegetable matter, sticks and seeds. Cotton ginning is usually located close to the farm, and in some cases is a cooperative model. The cotton gin was one of the first things that spurred the Industrial Revolution, both good and bad. As you can see from this diagram on the slide, there are many steps that go into this process. As I describe these processes, I want you to consider, again, just all these steps that we're talking about in this singular process. The module of cotton is open and cotton is moved with airstream into the gin, first passing through a bowl trap that removes green, bowls, and rocks. The airline cleaner takes out fine trash and sand. The separator removes cotton from the airstream, dropping it into the feed control, which regulates the flow of cotton into the ginning stream. The tower dryers dry the cotton if it is wet or harvested before the plant was completely dry. The incline cleaners are a type of cleaner that removes fine trash. The cotton burr and stick machine in a stripper cotton gin removes the sticks and burrs. The cotton then goes through a second dryer, another incline cleaner, a second stick machine. Another separator takes cotton out of the conveying airstream and drops it into a conveyor distributor. The distributor delivers cotton to each of the several extractor feeders, which feed the gin stands uniformly at a controlled rate. The gin stand is at the heart of the ginning process, where the fibers are removed from the seed. Most gins are equipped with 2 lint cleaners that remove small trash that remains in the lint after ginning. These cleaners are equipped with bypasses to regulate the amount of cleaning required. The fiber then goes into a gin press, where it is compressed into a 480-pound bale suitable for commerce. So once it's baled, every bale of US ginned cotton goes through a standardized process of measurement and classification conducted by the USDA before it can be traded to manufacturers. Each bale of ginned cotton has a sample taken from it, which is tested for key characteristics such as fiber length. In the industry, it's also called staple length. Those terms are used interchangeably. Strength, micronair or fineness of fiber, color, uniformity, and leaf content. The bales are then typically shipped overseas to be spun into yarn. Another cool thing that I found in this was that Eli Whitney's cotton gin wasn't a new idea. The churka, invented in India 3,500 years earlier, was very efficient at ginning long staple cotton. There are those long fiber cotton, but ineffective with the short staple variety. Whitney's gin was the first gin to process that shorter fiber cotton. And hand harvested cotton tends to have less vegetable matter than machine harvested cotton, but hand harvesting is super difficult, and I wouldn't wish that on anybody. All right, so here's a gorgeous high-level overview of what this beautiful fiber looks like from cotton wool to yarn. Let's talk yarn. The 480-pound bale of fiber from the cotton gin is usually shipped from the US to an overseas spinning mill. Before cotton is able to be spun into the yarn, fiber must be prepared. Once the bales arrive at the mill, they are puffed open to the state you see on the image on the left. The fiber is entering the carding machine. A carding machine is a series of wires attached to rollers. The wire rollers align the cotton fibers into a soft, organized state called sliver. Sliver is a continuous length of parallel fibers that have been gilled and generally combed. So now I'm going to refer to that combing process in the third image on the right. The difference of combed yarn from carded yarn is that it is produced using longer fibers obtained after the combing process. And this way, much finer yarn can be produced. This yarn, which is produced in high quality, has an extremely flat structure, softer, and has high absorbency. All right, so for cotton yarn, after it's turned into sliver, it now gets spun into yarn. There are two main techniques for cotton spinning in the industry. They're called ring spinning and open end spinning. And then they're on the very top right of the slide. That is a magnified view of two cotton yarns that have undergone each of those differing processes. Ring spinning is an extra step during which cotton is spun around a ring mechanism to create a finer, tighter gauge of thread. It uses longer fiber lengths and has been combed. The result is a noticeably softer shirt that doesn't pill or get holes as quickly as ordinary cotton. Bottom line, ring spun shirts feel better and last longer. Open end spinning uses shorter staple lengths, fiber lengths. It's cheaper but faster to produce and has the tendency to pill and has a rougher touch. The diagram on the left is of a ring spinning machine. In this instance, I'm using the term sliver and roving that's listed in this diagram interchangeably. Roving has a slight twist and is more common with woolen processing. The sliver/roving feeds down from the top of the guide into the drafting system. The drafting system elongates sliver and roving to make it finer and longer to spin. So it's just like pulling it apart. The fiber is then spun and rolled onto the bobbin spindle holder. As I mentioned, there are many ways and mechanizations this process can happen. And then the image on the lower right is usually what you see when you are in a spinning mill. If you haven't ever been in a spinning mill, which is it's really a rarity in the US if you live in the US and you're on this call. But I recommend you try to get a tour anywhere. I really think that mills are so cool to just go see, and it's good to just learn about it. So after leaving the spinning mill, the yarn then travels to the knitting mill. At the knitting mill, yarn is spun into a fabric called jersey. Jersey is a single knit cotton fabric. It's known for its stretch and softness. Because of how jersey is knit, there is natural elasticity without using stretch fibers like elastane. You'll recognize jersey as the fabric used to make a cotton t-shirt. That's what we're talking about it. Jersey fabric is thus named because it was first produced on the Channel Island of Jersey during the medieval era. And it was primarily associated in the 20th century with underwear, but now shirts. All right, so let's talk about how that yarn becomes a jersey fabric. This is called a circular knitting machine. A circular knitting machine knits jersey into a circular tube. This is an efficient way to knit yardage. There are also flat knitting machines, but circular knitting is the primary way t-shirt fabric is produced. Have you ever noticed that sometimes when you put a t-shirt on, it doesn't have any side seams, like seams right here? It's because it was knit on a machine like this. It does reduce labor and at the cut and sew factory, but it is 2 less steps for the sewer. See the yarn supply creel in the diagram on the left? The yarn is fed up into the tension control. If you've ever hand knit, you might understand that tension is everything for the outcome of the knit. The yarn goes through the stop motion controls and down to the knitting needles. The diagram below the machine is a diagram of the hooked needle and how the yarn is hooked into the existing knit chain. Underneath this circular row of knitting needles is a roll of fabric that is spinning in a circle. It is winding the newly knit fabric onto the take-up roll or bolt of fabric, if that's a better term. The thing that I really like, I like to watch videos of these machines in action or see them in real life. But the cool thing is, like, that bolt on the bottom is just spinning in a circle and it's rolling that new fabric up. It's really cool. All right, so this is what the fabric looks like on the left when it's knit up on that roll. And it's shipped to a scouring and dye house facility. And what is scouring? Why do we do it? So remember in cotton ginning, in that process, plant matter was removed from the cotton. Well, some of the vegetable matter remains in the cotton all the way to the knitted fabric. In addition to the vegetable matter, some lubricants and lint are knit into the cotton jersey. The image on the left shows this. The stage of the textile that you're looking at on the left is called gray or grayish material when in natural form. It's natural with color, odor, and impurity not appropriate for clothing. Not only are the natural impurities remaining on the gray material, but there are also additional products produced during cultivation. I read that their raw cotton has impurities such as water, nitrogen, mineral matter, waxes, and pigment residues. So in order to prepare this fabric for dyeing, sewing, it goes through this process called scouring. Bleaching can also be included in this process too. I found the following substances that can be used in this process. I don't know if anybody's a chemist because I'm not even sure what they all do or where they're from, but here they are. They're called trichloroethylene, perchloroethylene, soda ash, caustic soda, HS ultrafil, eco desize, PS10, and amino silicone fluid. There's also a heating process that burns off the vegetable matter in the end. That's sometimes called decarbonization. And a better scenario, there is a company that scours with just using hydrogen peroxide. It's a little lower impact and it forgoes the use of the chemicals. I'll talk about them in a minute. If the fabric is going to be a white t-shirt, then the fabric will be shipped to a cut and sew manufacturing facility. Depending on dye machinery, scouring can be done with the same machine previous to the dye process. So let's talk about dyeing. All right, so dyeing cotton has a large impact on the environment if it's not executed in a responsible manner. According to Mark Sumner, who authored the article, Following a T-shirt from Cotton Field to Landfill Shows the True Cost of Fast Fashion, Cambodia, for example, where clothing compromises 88% of industrial manufacturing, the fashion industry is responsible for 60% of water pollution. The dyeing process uses a lot of energy to heat the water. Most dye reactions occur at about 60 degrees Celsius or higher. The colored fabric then has to be washed and dried over and over to prepare it for the final stage, garment making. Along with the hot water, dyeing can have a long process time and requires large amounts of salt and alkali fixatives. I'm going to keep on talking about these fixatives. While both cotton and poly are normally colored with synthetic dyes, dyeing cotton is more water and heat intensive process. The surface of cotton fibers are negatively charged and they don't readily react with negatively charged dye compounds. Hence the salt and alkali fixatives are there to help them along. And I'll talk about that in a sec. Even with an assist from salts and alkali added to the dye solution, cotton only takes up 75% of the dye. So 25% of that is just going back into wastewater effluent. To ensure the color fastness, dyed fabric or yarn is washed over and over again in hot water, and that's creating large amounts of wastewater too. The following are statistics published by the UN Environment Program and the Ellen MacArthur Foundation. Every year, the fashion industry uses 93 billion cubic meters of water, enough to meet the consumption needs of 5 million people. Around 20% of wastewater worldwide comes from fabric dyeing and treatment. But why the use of salts and fixatives? Let's talk about that a little bit more. So Melanie Baumgartner states that in the same article in Chemical and Engineering News, cotton, one of the most widely used fibers, is dyed mainly using reactive dyes. We're just going to focus on those for the most part. In an article written in the Journal of Chemical Engineering and Process Technology, it states that the use of reactive dyes increased from 60,000 tons in 1988 to 178,000 tons in 2004. Cotton can also be dyed using dyes called direct dyes, indigo dyes, and naphthol dyes. But let's talk about why we're talking about reactive dyes. They are more expensive than other dyes, but they produce consistent color and good light fastness. The reactive dyes are sometimes called fiber reactive dyes. They're the most important class of dyes for cellulosic fibers, and they're also used to dye protein fibers such as wool and silk. They're capable of forming covalent bonds. And I just lost my script. Excuse me. All right. So let's talk about covalent bonds. All right, so what happens is once the salt and alkali fixatives are in the dye, they form a covalent bond with the actual fiber. Covalent bond, if you remember anything about high school chemistry, and you don't have to, but it's like one of the strongest chemical bonds because those electrons are just sharing with each other with the dye and fiber, and then they're at least dyeing they're using 75% of that dye, and that's just the best case scenario. The most relevant reactive dye systems are shown in the table above. I've used the Procyan dyes for my personal art practice, but when I actually learned to use them correctly, when you mix them, you're supposed to put them under a hood vent, and it really scared me because I don't have a dye lab in my own studio space, so I decided to start using a different dye stuff, just natural dyes because of that. And also in some cases, dye houses, this is super rare now, but dye houses don't have wastewater treatment facilities, and the effluent is dumped in rivers and other waterways. I read this. It has been said that you can tell what the Pantone color of the year is because of the colors of the rivers and regions that contain dye houses. Sometimes to hide this dumping, chemicals have been dumped in these waterways to neutralize the color. They're usually more harmful than the dye stuff and instantly kill marine life. I did see some research abstracts where people are starting to experiment and use this substance called chitosan, which is a derivative of chitin. It's found on insects and shellfish. It's being used to clean water wherever there's like a wastewater treatment facility present. All right, so after this dyed fabric leaves the facility, it's ready for cut and sew. This is one of the few steps that now require human hands to assemble. Depending on the factory, country, regulations, and protections, conditions for cutters and sewers vary. If you've ever been in a sewing factory, you may have noticed the noise, the repetitive task in an assembly line, or even unsafe conditions. I'll expand on this in a few minutes. But first, here are the steps required to assemble your simple t-shirt. If you've ever sewn with knits, you know it's both easy and difficult due to the elasticity of the fabric. Next time you're looking at a t-shirt, check out all the components. A simple t-shirt really isn't so simple. First, a shirt pattern is developed and vetted for fit. Once this is satisfactory, the fabric is cut into pattern pieces. This is done using a knife or a multi-million-dollar laser cutting machine. The slide here on the back, this gentleman is using a knife and he has a protective glove so he doesn't cut his fingers, hopefully. All right, so sewing is then completed after the pattern is cut. Usually a sewer will have a specific task in the process that they repeat over and over. And they're also pressing throughout this process too. I also want to note that ribbing trim at the neck of a t-shirt, getting that, if you have a V-neck t-shirt and getting that right on a knit shirt, right at the center front, seems like probably the hardest step in the process. And it just really does have to be perfect because that's everybody's focus. I watched a really great video on the assembly of this process of a t-shirt factory in LA. It's called Bella Canvas, and they brag that they produce 2.5 million t-shirts per week. If they're operating 50 weeks per year, that's about 125 million t-shirts a year. That is one factory. According to McKinsey & Company, clothing production doubled from 2000 to 2014, and the average consumer buys 60% more garments each year. At the same time, these clothes are kept only half as long as they were a mere 15 years ago. And that calculation that I gave you a couple of slides back about the increase of the reactive dye stuff increasing, I think that's obviously a correlation between this figure Most of our t-shirts are sewn in Asia, South and Central America, where working conditions are unseen to most consumers. This is due to global trade agreements, economics, and legislation. There are so many trade agreements that dictate where we are making things and how much we are paying for them. It makes my head spin. And in order to understand it all, I really do think you have to be an economist. And so I'm going to take a moment and talk about working conditions. And the picture that you're seeing in the background is the factory collapse of the Bangladesh factory, Rana Plaza. And this happened in 2013. I'm just going to recap what happened. The 2013 Dhaka garment factory collapse, killing more than 1,100 workers and injuring 2,600 more. It is the clothing industry's worst ever industrial incident. This had been an accident waiting to happen. Structural cracks in the building had been discovered the day before. Businesses on the lower floors, which were shops and banks, were closed immediately. There were 5 garment factories on the upper floors, and they made their workers keep working. On the morning of April 24th, 2013, there was a powder outage. Diesel generators at the top of the building were turned on, then the building collapsed. The official death toll is 1,132. All in all, just understand the industry is located where labor is cheap. As most countries experience industrialization, they have gone through a cycle where goods are made cheaply. This comes usually at a cost to people, land, animals, and water. Once this cheap labor and money trickles into the country, sometimes it allows for better working conditions and increased labor cost. Once that happens, the cheaper labor shifts to another country willing to accept lower paying labor and lesser conditions. According to the Clean Clothes Campaign, an organization backed by 230 unions, NGOs, and research bodies, they state that just 0.6% of the retail price of a t-shirt goes to the worker. The factory owner takes 4% as profit. The brand label takes 12% and the retailer takes 59%. So when I asked you the question at the beginning, how much was that last t-shirt you purchased and what went to the factory worker that sewed your shirt, which is 0.6%. I did that exercise and I quickly Googled some major US retailers to see how much a t-shirt costs. The average price of these 3 examples is $5.63. So if we multiply that by 0.6%, that is 3 cents per shirt. How is that fair? As brick and mortar sales have decreased, you may have increased your online orders. When you receive a t-shirt or garment in the mail, you may have noticed it comes in a poly bag. This bag is used to protect the garment from dirt, dust, and handling at the distribution center. Even when retailers receive boxes of garments, each garment can be enclosed in this bag. This is a statement that I found on the Patagonia website about their perspective on poly bags. Despite growing interest from brands to find sustainable options for poly bags, there is a lack of clarity and consensus on the best available materials and system improvements that deliver the same performance, but with decreased environmental impact. From e-commerce, a certain number of products will be returned to the distribution center. Return rates depend highly on the country and the brand. From their own interviews, industry return rates can be anywhere from around 30 to 50%. Garments will typically be inspected and if of good quality, packed in a new poly bag, and the old poly bags are discarded. Hopefully they're recycled. These repacking operations generate a significant waste stream at distribution centers, especially those of pure e-commerce players and those with high product return rates. So most of the poly bags are made from a substance called low-density polyethylene. Polyethylene is a polymer formed from the ethylene building blocks, which is mostly sourced from the refining and cracking of petroleum or natural gas. So what about bio-based plastics? The most common point of confusion is to confuse bio-based with biodegradable. I've done that a lot of times, and I'll probably still do it. Patagonia also conducted a study where they tried using different methods to reduce polybag use, but this is what they quoted from their study. If we eliminated the use of polybags, garments would be damaged, resulting in both financial and environmental cost. Energy, water, and resources are used to make each product, and we want them to be worn. A damaged product that is unwearable has a far greater environmental cost than manufacturing a polybag. So not all doomsday. There is a company and a brand right now that committed to getting rid of their poly bags. The brand is called Prana. They're located in Carlsbad, California. And from fall 2021 onward, 100% of their styles will have plastic-free packaging. They say that they're using roll packing and other paper bags as alternatives. There's a substance called Vela, V-E-L-A, that they said that they're using. So it doesn't end there. After the t-shirts are packaged in box, they're shipped to countries such as the US. The ship offloads the goods at a port, and the goods are then put on a truck or a train. They usually end up at a distribution center, and then they travel to a retail location or direct to consumer. If we have considered all the places the raw goods have finished to finished product have traveled at this juncture, it's kind of insane. And it doesn't even stop there. So once you purchase this shirt, you bring it home, you wear it, the cycle of impact doesn't end there. Let's talk laundering. This is the biggest impact in the process. So I did read that 1 load of laundering takes 40 gallons of water per load. There was a Swedish study of the t-shirt impact by Sander Roos. It states that the average Swede buys 9 t-shirts per year, and wears those t-shirts around 200 times per year. It gives an average of 22 wears per shirt per year, and they wash them on average once every 2 wears. I don't know about you, but like sometimes I just stink a shirt up on the first wear and I can't even wear it 2 times. So it made me feel really guilty about this. Beyond the washer and dryer, also think about all those huge plastic containers that we do buy detergent in. Are they really recycled? Probably not. How are they recycled? Where are they recycled? Are they shipped overseas to be recycled? And what's that carbon footprint? So what do you do when you're done with that t-shirt? Do you sell it to a resale shop? Do you donate it to Goodwill? Do you throw it away? And what about those bins that recycle clothing? So most of it ends up in a landfill or is incinerated. The EPA estimated that the generation of textile waste in 2018 was 17 million tons. This figure represents 5.8% of total solid waste generation for that year. Generation estimates for clothing and footwear were based in part on sales data from the American Apparel and Footwear Association. The recycling rate for all textiles was 4.7% in 2018, with 2.5 million tons recycled. I personally feel better if I'm donating clothing to Goodwill, but what really does happen to it? And by the time you're finished wearing a t-shirt, is it suitable to be worn again? Where does it end up? And I guarantee you, if you're buying a $5 t-shirt, it's not going to be suitable for reuse. Sometimes I'm guilty. I have bought a $5 t-shirt and it has gotten a hole in it within a week. And then, if you have a hole in something, where you can wear it over and over again, but it's just, not as useful. So less than 1% of used clothing is actually recycled into new garments. Most t-shirts aren't 100% cotton now. More and more, I'm just seeing more and more blends. And if they are, usually even like the thread is poly cotton, and if the t-shirt is printed, then that part needs to be cut out too. This aspect makes it nearly impossible to recycle. Fibers can be recycled using pre-consumer fibers. Cotton Inc. has listed both the challenges and benefits of pre-consumer recycled fibers. While there currently isn't an infrastructure for post-consumer recycling, I think it is coming. I'm starting to see a lot of companies start to pop up, and I'm really excited about it. But this one solution isn't really going to stop the entire impact. If you think about the energy that it will take to break those fibers down and respin them and reknit them into new fabric, it's just a lot. So I mentioned recycling. Let's dig into that. When you donate said t-shirt, it is sorted, baled, and sent to countries like Haiti and sub-Saharan African countries. While the price is right, the long-term effects of this have been known to disrupt local apparel economies. It isn't even addressing the CO2 footprint of shipping the goods from the US to these countries. A large portion of these previously owned goods ends up in market stalls across Africa, according to an Oxfam report. Used garments account for over 50% of the clothing sector by volume in many sub-Saharan African countries. Some of these shipped garments are actually unsuitable to wear, so after they are shipped overseas, they go straight to landfills or incinerators. So overall, it takes about 2.6 kilograms of carbon dioxide to produce a t-shirt. That's the equivalent of driving about 14 kilometers in a standard car. Am I depressing you yet? I hope not. I'll leave you with this last fact before we talk solution. Fashion makes a sizable contribution to climate change. McKinsey research shows that the sector was responsible for some 2.1 billion metric tons of greenhouse gas emissions in 2018, about 4% of the global total. To set that in context, the fashion industry emits about the same quantity of greenhouse gases per year as the entire economies of France, Germany, and the UK combined. I've listed some organizations on this slide that are helping you make positive change for this industry. There are a lot and they're all doing good, but because there are so many, sometimes as a consumer, I think it's difficult to understand what they're doing and who to follow. The industry has focused on the Sustainable Apparel Coalition's HIG index and also Blue Sign certification. It moves the needle, but really not enough. I do personally think that we need legislation to help regulate and set standards. So what can you do? So I would say, first off, if you're going to buy something new, shop at places that show supply chain transparency. So I'm wearing a t-shirt today that I bought from a company called Solid State Tees. They're located in North Carolina. On their website, it's almost hidden. They show full transparency of the process. They show who grew the cotton, who that cotton farmer was, where that fiber was spun, where it was dyed, what kind of dyes. This company does use both fiber reactive dyes, and they are dipping their toes in natural dyes. The shirt that I'm wearing today was dyed with pomegranates. So there has been pressure in the industry to commit to supply chain transparency, but you still have to dig for that info. So what else can you do? I want to leave you with a quote that I read in a report where misinformation in the industry is debunked by scientists and vetted data statistics. Jesse Daystar, VP and Chief Sustainability Officer of Cotton Inc. says, sustainability is complex and designers and brands want something easy and simple. Unfortunately, when people create single scores or other metrics simplifying the complex science for ease of business, bad things can happen, one of which is misinformation. And I'm not going to go over all these points, but I want you to leave this with the first point is just be skeptical, ask a lot of questions, be curious, do research. You know, I know that everybody's busy and like you have everything to research and be conscious about, but whenever you see the word sustainable fashion, just be skeptical. And then demand better from the places that you buy. Let your dollar do the voting, and therefore dictate to companies what and how they should make clothing. I do think that they will listen. So thank you.